Hi everyone, this is Ziyuan Guan, and this is my final project of the wireless communication course. The name of the project is the application of vehicle-to-vehicle model with 5G wireless communications. Firstly, all around the world we know the traffic accidents rate is pretty high. It's almost 23% and even much higher in some areas. So the urgent request of the automatic driving is more and more important right now. Since the vehicle to X, it means the vehicle to vehicles or vehicles to infrastructure maintenance technology has developed for so many years. For different models and methods have been uploaded and tested. However, the development of V2X models should be based on the high-speed, reliable, and high-quality networks and the transformation of messages. So with the coming of 5G network, it is a great chance to simulate the V2V and V2I models in ad hoc systems with 5G. Look at the pictures below. This is two models to show the 5G and also the V2X models. And then, during the research, I found an article called On the Application of Network Slicing for 5G V2X. In this article, the author tried to use the network slicing method to pursue fast and high-quality network services. The network slicing diagram is shown here, and with the application of network slicing, we could split the complex functions into several sub-steps and then apply it into V2V scenarios. Actually, use the network slicing, we could split the physical network into several virtual networks. It could reduce the pressure of the network and supply some pretty good services to the multiple users. So, for the existing approaches in this article, we could know that the system used the single input, multiple output as a scheme with orthogonal frequency division multiple access, which is mean the OFDM. And since in the practical situation, the sensor should share the information with many other nodes. For the roadside units, we use the GSCM model. In this model, we could put the roadside units as best as practical things. We also use the link to system interface for modeling and use the channel quality information for the evaluation parameter. These things could be used to improve the system and also judge the system. And third, the ACK, which means an acknowledgement, is generated for the successful transmission, and a negative acknowledgement could represent the failed transmission. These things are used to test the system, and also we use the hybrid automatic repeat request used for retransmission when we meet the failed frames. The most important of this article, we use the network slicing, and we use the network function virtualization method to apply the network slicing. We're gonna split the physical network into multiple logical networks. And for example, the autonomous driving slice and a video stream slice for different services and different requests by multiple users. During the performance evaluation of existing approaches, we need first analyze. We need first assume the scenario, and we need to build some channel parameters. The left picture shows the parameters we build. First, we use the duplex model. We use the FDD. We use the vehicle speed as 140 kilometers per hour. It is pretty high because we assume it is in a freeway modeling in the in the highway. And also, we actually tested 3 different scenarios with different distances. The distances means the safety distance, and also we use the roadside units distance could be the 1,732 meters. It is actually a practical thing which we can put the roadside units inside the inner system. And also here we build some technologies to compare with each other to evaluate the network slicing efficiency. First, we should have the roadside units. It is a normal thing we need to compare with, and we're gonna compare with the roadside unit with roadside units and relaying. With the relaying and the roadside units, it's gonna show the high quality of V2I and V2V links. And also, we will compare the normal roadside units with the network slicing services, and network slicing services with relaying service. With this comparison, we're gonna know the performance of the existing approaches. And right here, this is the results of after the simulation. We can compare them from the upper side with the bottom side. So for the normal roadside units places, actually we could say everything should be the same. But if we use the network slicing, it's gonna be increased much better, at least 2%. And also, especially when we improve the communication range, especially to the 200 to 300 meters, we could see the network slicing without the relaying is much better than the network slicing with the relaying. And also, the network slicing is much better than the normal roadside units communication. So in this way, we could know the network slicing method is pretty good, and actually it can pursue a fast and reliable network during the V2V models in the 5G situations. So this is a conclusion we got from the article right now. Actually, there are many advantages of this article. They also came up with a good idea to achieve a reliable and high-quality network and prove it well with experiments. The explanation and illustration of methodology is clear and detailed. The simulations considered the freeway driving model and tested the system with different communication range. The comparison with a combined network obviously showed the advantages of network slicing, and actually it could used in the practical scenarios. But however, it has some disadvantages because the author just focused all of the attention on the analysis of a network communication. He got a lack of the consideration of complicated mobility models in practical life. They also only explained the high quality and fast speed of sliced network, but didn't consider the cost of network function virtualization. Actually, if we use the network slicing, we're gonna split the physical network into several virtual networks. It actually costs much different things. It costs more equipment to build the network. And also, the simulation is based on the simple network slicing. The number of slices is only 2. As if for example, the simulation inside the article only take the autonomous driving slicing and the video stream slicing. It's only 2. But the practical life requested much more slices of the network. So the paper should add the simulation of this kind of situation. The slices, the number of slices should be much higher. So during these things, I did some personal simulations to simulate more mobility models. For the V2E and V2I models, actually, I got some simulation by the MATLAB code here. This is a V2V simulation. First, we're gonna draw 2 lines in the picture. These 2 lines means 2 different roads. And the 3 points here means 3 different vehicles. When they're moving, we could say when they are close enough, they're gonna have connections with each other. They're gonna have communications and change the messages between each other. This is one of the situations. And also, if we try a different situation like this, we could say more of them could communicate at the same time, not just one by one. Okay, in this situation, these 2 vehicles have communication. Actually, if this vehicle could run a little bit faster, they could communicate with each other one by one. So we're gonna try again here. we can see here, there we got more communications between one by one. So there are multiple communications between vehicles. So it means the V2V connectivity is actually complicated situations. It's not just one vehicle to connect with other vehicles. Actually, it could happen like separately, and also they could happen multiply at the same time. And the next is V2I simulation. First we got the road 1, and then we got the road 2 here, and then we got the road 3. This is actually a crossing road, and we put the roadside unit right here. We could see, and then roadside unit here. We could see this is the track of the vehicle moving. And when it is close to the roadside unit, it has a communication with the roadside unit first. And when it's outside the range, it could stop the communication. But actually, it could not have the communication with the roadside unit second. So let's simulate it for the second situation. So in this case, we have two roadside units in the same way, and actually this vehicle could have the communication with both of them pretty good. So in this case, this is a simulation of vehicle 2 infrastructure. It could show that actually this is also a complicated simulation. The one vehicle, this is a single input and multiple outputs, so it has a communication with different roadside units at the same time. And also with the simulation for the VanNet mobility simulation, we could get some results here. First, the average V2V connectivity with a different communication range from 50 meters to 150 meters. We could see actually at first it is linear with different traffic density. It's gonna increase with the density rises, and also with longer community range, we could get much higher connectivity. Actually, this is the same as expected as in practical scenarios. For saturation and duration of the connection, we could say this is weird here, because when the traffic density is very high, and also for the communication range, the duration of the communication actually is based on the traffic density. If the traffic density is very high, even the communication range is different, actually they could only have the same duration, because the vehicle neighbors could locate equally at the same positions. They could not change randomly. And also for the average number of same neighbors for 30 seconds, we can know it's linear to the traffic density. When we got the higher density, the average number of the neighbors could be higher. This is also as expected as the practical things. And also with the communication range higher, we could get higher average numbers. It means when the communication range is higher, the single input and multiple output model gonna be very obviously. And also with other simulations, we could know when we use the millimeter waves of 5G network, we could get like a pretty good communications and high quality channels with V2V models. This is pretty good, and actually in the most of cases of practical things, the V2V models could build and run smoothly in most of cases, because the 5G wireless network is actually much more reliable, much faster than before network. And also for the complicated conditions, we could only use the network slicing technology or some other different ways to split the complicated network into several sub-networks or some like small networks to reduce the pressure of the network and provide multiple users with multiple services. So thank you for your listening.